So our next speaker is Larry Griffis. Larry Griffis is the president of the Structures Division and a senior principal at Walter P. Moore, a national civil and structural engineering firm that I'm sure everyone knows about. Larry has also been very active as well with professional organizations such as he's a member of ASCE 7, as well as the past chair of the wind subcommittee of ASCE 7, or task committee of ASCE 7. I've been past president of the Applied Technology Council, a member of ASCE Committee on the Design of Steel Buildings, and very active with AISC and the Code of Standard Practice Committee, as well as the main Committee on Specifications. It received from AISC both the T.R. Higgins Award as well as the Lifetime Achievement Award. And just to show that Larry's not just a steel guy, he was also recently named a fellow of the American Concrete Institute. So with that, I'll invite Larry to give his presentation on structural engineering practice, instilling a culture of discipline. Larry?
Well, thank you, Jim, and good morning, everyone. It's indeed an honor and a pleasure to be here before this group. I had the pleasure to be here several times before, so this is a really great gathering. My presentation today will focus on this great practice of structural engineering and some of the challenges that I think we face as we move forward into the future. I'd like to begin with a story about the French engineer Gustaf Eiffel. Early in my career, I was given a book by one of the great builders down in Texas named Warren Bellows. Warren had a great influence on my life, and he was always sending me all kinds of stuff to read. One of them was this book on Gustaf Eiffel. Warren was head of a very great builder named W.S. Bellows. W.S. Bellows was responsible for building the San Jacinto Monument and probably most of the high-rise buildings in downtown Houston. Gustaf Eiffel was an accomplished bridge engineer. That was his trade. One of my favorite bridges that he designed that I like to refer to every now and then is this bridge in Portugal. Note the grace and elegance of this structure and the expression of structure as architecture. This indeed was one of the traits of Gustaf Eiffel. And many of you may or may not know that Eiffel was responsible for bracing the structure, America's own Statue of Liberty. The story of the Eiffel Tower begins in about 1887. The tower was a celebration of the Centennial Exposition of 1889, which was commemorating the 100th anniversary of the French Revolution. The commission there conceived a design competition. There were more than 100 proposals received, and the one that came in first was won by bridge engineer and metal iron worker Gustaf Eiffel. His low bid was an incredible 1.5 million francs, which, by the way, was significantly below the 6.6 million francs that he estimated would be the construction cost. So, Mr. Eiffel, being a businessman, apparently negotiated that he would get all the concessions for the exposition in addition to the privilege of building the tower. And for his efforts, he also received a whopping first prize of $800. The Eiffel Tower has many great innovations, and I would encourage all structural engineers to read about Eiffel and his tower. At the time he designed it, it was the tallest structure in the world at 300 meters. And that record stood until 1930 when the Chrysler Building overtook it. The curved form was tailored to the overturning forces of the wind. This was an aspect of this tower that Eiffel was very proud of. The project contained 7,300 tons of wrought iron, far more than any structure of the day. and a whopping 2.5 million rivets. He produced over 5,300 drawings that contained 18,000 pieces. Many of them came pre-assembled to the site in 5-meter pieces. The foundations were a whopping 6-meter thick, 6-meter diameter by 15-meter long compressed air caissons, the first of their kind, were underneath and provided the foundation. The tolerances were exceedingly tight for the day, rivet holes to 1/10 of a millimeter, angles on the curved surface of the legs to 1/2 of arc. It was the first use of steam-powered winches and cranes anywhere. The elevators were novel for the time, ascending the inclined legs to what was then record heights. And what's really amazing, we think we build things fast today, the Eiffel Tower was constructed in 22 months. It was ahead of schedule, and amazingly, there was only a single fatality during construction, and that was after hours. The reaction to the tower's design was not good. This was very discomforting to Gustaf Eiffel because the esteemed writers, poets, painters, sculptors, and architects of Paris declared that it was a useless and monstrous tower, a barbarous mass overwhelming and humiliating all our monuments. Eiffel's response was beautiful and I think very classic. For my part, I believe the tower will possess its own beauty. Are we to believe that because one is an engineer, one is not preoccupied with one's construction, or that one does not seek to create elegance as well as a solidarity and durability? Is it not true that the very conditions which give strength also conform to the hidden rules of harmony? I hold that the curvature of the monument's 4 outer edges, which is as a mathematical calculation dictates that it should be, will give a great impression of strength and beauty, for it will give the eyes of the observer the boldness of the design as a whole. Really great words for an engineer, huh? I think, though, the genius of Eiffel was not just in the fact that he designed the tower himself, but he built it, and believe it or not, he financed it himself. He took all the risk for schedule and cost. So to me, the legacy of Eiffel is that he not only was a great bridge engineer, but he produced elegant designs that evoke structure as architecture, something that all of us should think about today. And finally, his meteorological studies that he did on the tower in his later years when he actually lived there earned him the title of the father of wind engineering. So Don, we need to remember that. I believe that engineers today can learn from the work of Eiffel and the culture of discipline that he clearly exhibited in the design and construction of his tower. Today's structural engineer is called upon to design structures that reach taller, span further, take a myriad of forms and complex shapes, as we heard this morning from some of our great architects, and we're called upon to deliver them on a fast-track basis. We operate under complex contracting procedures and multiple team members. I can remember one project we did recently where there were as many as 18 team players on the project. And we operate under ever faster construction schedules with limited budgets and financial resources. And of course, we do all this on lower and more competitive fees. All the while, we are entrusted to protect the health, safety, property, and welfare of the public. The structures we design carry heavy loads, transmit enormous forces, putting ourselves and the public at great risk on an everyday basis. There are sobering risks in this business that all of us that practice it should be well aware of. Society and our legal system, frankly, do not tolerate mistakes. Perfection is expected. If we make a mistake, we're probably going to pay for it. And at the very least, we're going to be subjected to a long, litigious process like we have in the United States. And all of us should be ever mindful of the horrific event that occurred in July of 1981, where the Hyatt Walkway collapsed and killed 111 people, injuring another 216. This event probably changed a lot of the practice of structural engineering forever, and it all occurred because of a certain hangar detail. And when I think about this, I always like to think about the phrase, "The devil is in the details." Structural engineers are operating in a changing work environment. We deal with longer and more complex codes that are changing at a dizzying pace. And on the subject of codes, let me just add that a couple of years ago at the Structures Congress in Austin, I chaired a panel that discussed this particular topic. The trends are unmistakable. If you look at all of the major codes and specifications that we deal with, they're expanding on an exponential basis. If you look at the ACI 318 code, it literally is doubling every 25 years. If you look at the AISC specification, and this is code and commentary now, it also is on a pace to double every 25 years. If you look at ASCE 7, it's even on a more rapid pace. So I think this is both good news and bad news. The bad news is the trend is unmistakable. The good news is, as Ron and others have spoken here today, there's a lot of code groups, of which I'm a part of, are starting to spend a lot of time on how to deal with this problem. Perhaps the trend toward performance-based codes is the answer. Certainly we will see. Let me comment on perhaps what might be a little bit of a touchy subject, but I'm going to go ahead anyway. And let's talk about the architect as team leader. My experience over the last 30-some years is that every 4 or 5 years that go by, I see the architect taking a diminishing leadership role and capability as prime consultant. Not sure why that is, but clearly there's more emphasis on award-winning design, sustainability, and some of the other things that our architect friends are wanting to do these days. Less on constructability and quality of construction documents. This unfortunately puts a much bigger reliance on the structural engineer to figure out the complex geometry and detail the building. I think many of you in this room know that the structural engineer drawings almost always go out first in a phased construction approach these days. And oftentimes we are the ones that lead the 3D model and do the BIM model. Well ahead of the architect. I think this creates both a challenge and an opportunity for structural engineers. The challenge clearly is more risk and responsibility to get the project completed in a way that avoid disputes and litigation, and that's getting to be a bigger and bigger challenge these days. There's an opportunity though, and the opportunity is for engineers to step up and seek a prime role on projects where it makes sense. And there are many projects out there like parking garages, pedestrian bridges, even stadiums where the bulk of the cost of the building is structure. But if we're going to step up and fill this role, I think we're going to have to broaden our horizons a little bit, learn more about construction management, and be prepared to be the leader of the team, because clearly it is a different role than the traditional structural engineering role. I believe to achieve success or even survive in this challenging field that we all have decided to be in, we have to teach and practice our own culture of discipline. I think as a group, we all know that structural engineers are already working harder and harder. Now I think we have to learn how to work a little bit smarter and try to figure out what is our place on these design teams, and can we do more than what we're doing now? I've observed that over the years in today's construction practice, it's certainly imperfect at best, but it does have its own checks and balances. The first check is that we should learn to build the quality in the design as it evolves. Recognize that design is an iterative process, particularly in today's architecture. You're going to take 2 steps forward, and invariably you're going to take 1 step backward with all the changes that you're going to be faced with. And I think the changes that we have to deal with these accelerated schedules and putting structural packages out early is a big part of the problem. We're frankly just being overrushed to do our work. We need to have a safety net of a formal QC process, I believe, in all of the structural firms. The second tier of checking can come from shop drawings. Shop drawings is an opportunity for structural engineers to look at the project one more time and see if there are anything that doesn't look right or anything that we want to change. The change might be painful, but it is the second opportunity to modify the design. We should take the shop drawing process very seriously. The last tier of checking, though, is in the construction process itself. We need to listen to the feedback from the field, and I think structural engineers need to perform more site observation, not less. And I think we should always try to seek payment for more and expanded field trips to control the quality of construction. Many times we've been successful in selling additional services on some of our big projects, and invariably we find that the projects go better, to the fact that sometimes the contractors even rely on our field observers. They actually tend to become part of the construction staff. The net result is the job just goes better. Speaking of feedback from the field, I'm reminded of the Quebec Bridge that collapsed in 1907. This was a story that was told recently by Dr. Joe Ura when he received the Beadle Award from the Structural Stability Research Council. He mentioned in his paper that the cantilever construction method that was used in the erection of the Quebec Bridge realized significant rotations and deflections at the end of the cantilever. The field people cried out that the structure was moving, and their cries went unheeded by those that were in responsible charge of the erection process. The result was 19,000 tons of structural steel crashing into the St. Lawrence River. The moral of that story is pay attention to what's going out in the field and listen to what they tell you. I've developed my own list of avoiding problems in the design process over the years, and I keep this list on my desk all the time. I even have developed a laminated card that I carry around in my bag to remind me on a daily basis of some of the responsibilities we have as structural engineers. Now, none of this I'm going to tell you is rocket science, and everyone in this room knows that you need to do these things. But one of my roles these days is to dig into some of the problems that we have on our projects and figure out why we have these problems and what we can do about them. And what I invariably have found is that one or more of this list that I'm about to go through with you wasn't done to the level that it should have been done, and it could have avoided the dispute or the litigation. Number one, review the work as the design progresses. In the era of fast-track construction, your own review may be the only review that the project ever gets. Plan the work and work the plan. I think all of us have heard that before, which reminds me of a quote by Paul Bear Bryant some years ago when he said, "Have a plan, follow the plan, and you'll be surprised at how successful you can be. Most people don't have a plan. That's why it's so easy to beat most folks. This coming from Paul Bear Bryant. Always help your fellow designers and review each other's designs. You know, we as engineers sometimes go back in our corners and do our work, and a day will go by and we're buried in our calculations and we never even speak to anybody. I'm a real big believer in the buddy system. If you're designing something that you'd like somebody to take another look at, pass it on to your comrade across the aisle there and help each other. Practice collaboration. I believe engineering is best practice as a team sport. Many of these grand projects that we all work on are thousands and thousands of man hours. And the best job is always the job we do in the spirit of collaboration. Know your software and its limitations. I think we can all appreciate that statement. Always draw details to scale. And as I mentioned earlier, the devil's in the details. When conditions vary, like you have in many concrete structures or foundation conditions, develop a solution that bounds the answer. So you always know the limits of performance of your structure. And this is one I always like. Analyze what you design and design what you build. I'm reminded of the collapse of an arena in Kansas City some years back where this very thing wasn't adhered to. The actual structure that got built was far different than the structure that was analyzed. Study the deflected shapes under load. It can tell you an awful lot about the performance of the structure. Is it behaving as it should be? And frankly, I'm amazed at how many of our young engineers jump into the SAP model or the ETABS model without really looking at these deflected shapes. I find that you can find a lot of your own problems on input if you really study these deflected shapes. And the corollary to that is examine the frequency and the mode shapes. They can tell you an awful lot about the structure and its behavior. We tend to do that a lot more on the West Coast, I think, than we do on the East Coast. And I think East Coast engineers could benefit by studying mode shapes and frequencies a little bit more. Always test your solution with an alternate approach. Every structure that I am involved in the design, I like to do in a very approximate, quick solution, draw it up, and then have it tested by another solution, usually the more accurate and final analysis. But you know, if you discipline yourself to do an approximate approach to your first design, you begin to develop a really good feel and appreciation for the structure and its performance. I find this very important. Review drawings and details for accuracy, coordination, and constructability. I think that goes without saying. The problem is these days, and our engineers say it all the time, we just don't have time to do that. Well, there's an old saying, you can pay me now or you can pay me later. Review the shop drawings and the RFIs carefully and timely. We all know that in dealing with contractors that one of their strategies when a project gets in trouble is to go back and say that the design team delayed the construction process, there wasn't timely review of submittals, and you find that a lot of the disputes you get into or involve late shop drawings or responses to RFIs. And one of my favorites, I think we as engineers need to reach out to fabricators, erectors, detailers, contractors early in the project to get a better handle on cost and constructability. Some of the best projects I've ever worked on have been projects where I had the fabricator and the erector on board and we were able to brainstorm different ways to do it long before the drawings went out. Unfortunately, we don't see that process as much as we should. Perhaps it'll come on more as design build begins to expand. But that doesn't and should not stop us from reaching out to these players on the construction team that can really inform our designs. And one of my pet peeves, produce designs that respect proportion and the elegance of structure as architecture. What better way to remind ourselves of that than to go back and look at some of the beautiful designs that Gustaf Eiffel produced. And I saved the best one for last year because every single dispute or argument or every lawsuit that we get involved in always boils down to the issue of communication. We all need to practice good communication among all the project stakeholders. Invariably, a dispute will arise, and it's because somebody didn't tell somebody else on the design or construction team some important fact that he needed to know to do his work. So document, 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 communicate, communicate, communicate. Let me close by saying that I have found that structural engineering is a very exhilarating profession. I take a lot of pride in looking at some of the structures that I've been able to participate with our firm. And I think that's probably what keeps most of us going here. I don't think any of us are making tons of money, are we? If we are, if any of you are up there, let me know. I've been fortunate to be able to work for a company that has been able to design buildings that reach tall, or work on roofs that span long distances, and all crazy kinds of shapes of buildings, from pyramids to whatever these architects, black cake architects can dream up these days. Even right down to some of the things we see in these theme parks that are either humorous or downright ridiculous. But let me say that regardless of the kind of structure that you design, a structural engineer must approach his or her work with diligence, a great sense of personal responsibility, and a great sense of responsibility to oneself, to one's company, and to society as a whole. And let me say that in the spirit of Eiffel in this tower, I would impress on structural engineers today the need to develop their own culture of discipline. Thank you very much.
Questions for Larry?
All silent. I guess they're meditating.
Let me ask one, Larry. What do you think? Sorry. What do you think about the integrated design process that's becoming sort of a fad these days?
I think it's a step in the right direction. Seems like there are a lot of processes out there that have buzzwords by them, but there's no question that the more teamwork that we see on a project, the more collaboration between the designers and the builders, I think the better the project's going to go. So it's certainly a step in the right direction.
Other questions for Larry? We do have a mic if anyone has a question.